Now let us discuss about another one. Earlier we have discussed triangular law of vector addition. Now we are going for parallelogram law of vector addition. So as for statement concerned, you read this. If two vectors are represented by two adjacent sides of parallelogram, then resultant is given by the diagonal of the parallelogram passing through the point of intersection of the two vectors. So here, if two vectors are represented by the two adjacent sides of a parallelogram, so A is adjacent to B, okay. So this is vector A, OP is a one line and that is represented as vector A. Then you can take another one, that is Q point, and this one is R point, clear. OPQR makes a parallelogram, clear. So now this OP and OR are the two adjacent sides of a parallelogram, okay. So by taking two adjacent sides of a parallelogram, then after addition of these two vectors, vector A and vector B, we will get a resultant vector, that is R. This R is taken from the point of intersection of the two vectors. You read this. If the two vectors are represented by the two adjacent sides of the parallelogram, then resultant, this R, resultant is given by the diagonal of the parallelogram. If I take complete line, then if you extend this and if you close that figure, it seems to be a parallelogram, that is OPQR is a parallelogram. Then the resultant is given by the diagonal of the parallelogram passing through the point of intersection of the two vectors. This resultant is passing from where? Point of intersection of the two vectors. So we are taking vector A and vector B. In that vector and vector B, so this is called point of intersection. Through this only we are taking the diagonal of the parallelogram, that is vector R. What is it? What is this? Vector R is the sum of the two vectors, that is vector A and vector B. After adding vector A and vector B, we are getting a resultant vector, that is R, and its magnitude can be written as R is equal to square root of A square plus B square plus 2AB cos theta. Remember, this is very important. So this formula is used for all the vector quantities, either it is velocity, force, acceleration, momentum, okay. So you take any vector quantities, we are going to represent with this formula, and its direction is represented as, first of all we have taken theta is the angle between vector A and vector B. From vector A to vector B, angle is theta. Then with respect to resultant, alpha is the angle. Understand carefully. Alpha we have taken from this vector A to resultant, that is alpha, and similarly beta we have taken from resultant to vector B. So that is the reason, if I am taking with respect to horizontal, I mean in along x-axis. So if you want to go for representing the direction along x-axis with respect to x-axis, then along this OP, x-axis means this along OP, then I can represent the direction of this resultant vector as tan alpha is equal to B sin theta divided by A plus B cos theta. Then how to remember this? You know, when I am taking alpha, then beta will vector B will come here. Tan alpha is equal to B will come as a you understand that, but what it is falling on that, like that you can understand. Vector B is falling on that. So it's falling on the resultant vector, that is tan alpha is equal to, tan theta definition is sin theta by cos theta, sin theta by cos theta. Just you write B here, B sin theta divided by B cos theta, and addition of A plus B cos theta. Then coming to this tan beta, then A seems to be falling on that. You understand like that. A seems to be falling on that. Tan beta is equal to, so A sin theta divided by A cos theta plus B. B should be added. So you understand and remember this direction, very simple manner. Tan alpha is equal to, I told you, tan theta, how can you write? Sin theta by cos theta, right? So when you are writing this angle, what you have to do? You should understand that vector B is falling on this towards vector A. I mean this vector B is falling on this resultant, you can consider. Okay, so that is tan alpha is equal to b sin theta divided by b cos theta plus a. Then if you are taking beta, then vector a falls on this side. Understand that tan beta is equal to, that is a sin theta divided by s a cos theta plus b. Clear? So we should understand this. Then this derivation, if you want, then I will derive this. So as for competitive purpose, you must remember only formula, this resultant and its direction. We will show maximum, minimum, and when the two vectors are said to be maximum and minimum. Now we will discuss that.